NASA's discovery around Saturn so far. The second largest planet in our solar system, Saturn, is one of the 6 planets from the Sun. Saturn has amazing facts that you need to know. Hey guys, welcome back to the channel, All Things Space. We are back with another blockbuster video. In today's video, we'll explore the beautiful Saturn and also try to explain all those amazing and informative things that NASA's discovered so far. Saturn is unique among the other planets. It is adorned with thousands of beautiful ringlets. It is not the only planet to have rings made of chunks of ice and rock, but none are as spectacular or as complicated as Saturn's. Like fellow gas giant Jupiter, Saturn is a massive ball made mostly of hydrogen and helium. Let's get started with the top Saturn discoveries. But first, if you're new to the channel, please subscribe so you don't miss any future videos. NASA has discovered many amazing things about Saturn, and the first one is, Saturn is a colossal planet. With a radius of 36,183.7 miles, Saturn is 9 times wider than Earth. If Earth were the size of a nickel, Saturn would be about the size of a volleyball. At an average distance of 886 million miles from the Sun, Saturn is 9.5 astronomical units away. 1 astronomical unit is the distance from the Sun to the Earth. From this distance, it takes sunlight 80 minutes to travel from the Sun to Saturn. Short day and long year. Saturn has the second shortest day in the solar system. One day on Saturn takes only 10.7 hours, the time it takes for Saturn to rotate or spin around once, and Saturn makes a complete orbit around the Sun, a year in Saturnian time, in about 29.4 Earth years. Its axis is tilted by 26.73 degrees about its orbit around the Sun, which is similar to Earth's 23.5 degree tilt. This means that like Earth, Saturn experiences season. Saturn is a dim light world. Saturn shines with an ochre or golden hue, which is produced as sunlight reflects off its upper atmospheric clouds. The chemical responsible for the yellowish tinge is ammonia, which exists as a trace element in the hydrogen and helium-rich atmosphere. Saturn's complex atmosphere is infused with reds and blues caused by the presence of hydrogen sulfide and water vapour, and the planet would resemble Jupiter if it didn't have such a heavy cloud cover. Saturn is a smaller planet than Jupiter, and its gravitation isn't as strong, which is why its cloud layer is thicker and rarely separates to reveal lower layers. NASA discovers the largest ring around the Saturn. NASA's Spitzer Space Telescope has discovered a massive ring around Saturn, by far the largest of the giant planet's many rings. The new bell is located in Saturn's far reaches, with an orbit tilted at 27 degrees from the plane of the main ring. Most of its material starts about 6 million kilometers away from the planet and extends outward for about another 12 million kilometers. One of Saturn's most distant moons, Phoebe, orbits within the newly discovered ring and is likely the source of its material. Saturn's newest halo is also thick. Its vertical height is about 20 times the planet's diameter. It would take about 1 billion Earths stacked on top of each other to fill the ring. The ring itself is thin and consists of a thin array of ice and dust particles. Spitzer's infrared eyes could see the glow from the coal dust on the tyre. Launched in 2003, the telescope is currently located 107 million kilometers from Earth and orbits the Sun. Saturn's latest addition could explain how Cassini Regio came to be. The ring orbits in the same direction as Phoebe, while Iapetus, the other rings, and most of Saturn's moon all go in the opposite direction. According to the scientists, some of the dark and dusty material of the outer ring moves inward towards Iapetus, and the icy moon hits the windshield like insects. The ring would be difficult to see with a visible light telescope. The particles are diffuse and can even extend beyond most of the ring material into Saturn and into planetary space. The relatively small number of particles in the ring wouldn't reflect much visible light, especially near Saturn where sunlight is weak. Before Spitzer's coolant ran out in May and its warm mission started, these observations were made. High altitude winds from Saturn produce a spectacular aurora. Scientists measured infrared emissions from the gas giant's upper atmosphere using the Keck Observatory in Hawaii and mapped the varying flows of Saturn's ionosphere far below the magnetosphere over a month in 2017. This map, when fixed against the known pulse of Saturn's radio aurorae, showed that a significant proportion of the planet's aurorae are generated by the swirling pattern of weather in its atmosphere and are responsible for the planet's observed variable rate of rotation. Researchers believe the system is driven by energy from Saturn's thermosphere, with winds in the ionosphere observed between 0.3 and 3.0 km per second. Dr. Tom Stollard, Associate Professor of Planetary Astronomy at the University of Leicester, added, "This search for a new type of aurora harks back to some of the earliest theories about Earth's aurora. We now know that aurorae on Earth are powered by interactions with the stream of charged particles driven by the Sun, but I love the name aurora borealis originates from the dawn of the northern world. These observations have revealed that Saturn has a true aurora borealis, at least the first ever aurora driven by the winds in the atmosphere of a planet. Age of Saturn's moons can be determined via elliptical craters," Ferguson said. "Our work aims to answer the broader questions of how old these moons are. To get at this question, my colleagues and I mapped elliptical craters on the surface of these moons to determine their size, direction and location on the moon. Elliptical craters are rarer and form from slow and shallow impacts, which makes them especially useful in determining an object's age because their shape and orientation also indicate their impactor's trajectory." Ferguson was not expecting to find a pattern among the directions of the elliptical craters, but she eventually noticed a trend along the equator of Dione, one of Saturn's small moons. The elliptical craters were overwhelmingly orientated in an east-west pattern, while the directions were more random close to the moon's poles. Ferguson also mapped elliptical craters on Tethys, Saturn's fifth largest moon, and found that a similar size frequency distribution of craters is unusual for objects orbiting the Sun, but curiously matches estimates for the impactor population that appears to be present on Neptune's moon Triton. Because that population is thought to be planet-centric or drawn in by the ice giant's massive gravity, Ferguson's results point to the importance of considering planet-centric impactors when examining the age of objects in the Saturnian system. Is there life on Saturn? Unfortunately, no. Saturn cannot support life due to it being a gas giant. It's composed of gases, mostly hydrogen and helium, which are not good for organisms. Saturn has a substantial core made of stony substances and metals. Extreme heat and high pressure cause it to solidify, rendering it uninhabitable. The RV cannot be parked anywhere on Saturn, and even if it could, it would not be suitable for human living. Its weather patterns are just too harsh for any living thing that exists. Conclusion: one of Saturn's moons could be able to support life, but Saturn itself cannot support life as we know it. Titan, the biggest moon of Saturn, possesses an atmosphere, mountain ranges, liquid lakes and rivers, and maybe even volcanoes, among other encouraging evidence. NASA intends to launch the 8-year-long Dragonfly spacecraft in 2026. The Dragonfly will go to several regions on the moon, evaluate the environment and search for indications of past or current life for around 3 years while studying Titan's surface. Before the Dragonfly mission in 2026, NASA will continue to study Titan's characteristics to learn as much as they can. Can Titan truly give life everything it needs from a planet, organic molecules, liquid and an atmosphere? And is that all life needs from Titan? Possibly, we'll discover soon. And with that, we've come to the end of our video. Share your thoughts about the video in the comments below, and don't forget to give this video a thumbs up, subscribe to our channel, and we'll see you next time. Thanks for watching.